We are privileged to have a distinguished speaker, Dr. Indivar Gupta. So Dr. Indivar Gupta has did his PhD from IIT Delhi. He has more than 25 years of experience in the field of cryptography and is a very well-known figure in the cryptography community and of course security also. He has supervised many PhD students and he has written more than 50 plus research papers. He has served as a senior scientist in DRDO and currently working as Scientist G and a Center Director in Government of India. Sir, any opening remarks from your side so that with your opening remarks then we will start the question answering session.
Very good afternoon to all, esteemed guests, distinguished speakers, colleagues. So it is a truly honor to address this distinguished audience at PKI India conference. This is a primary platform bringing together researcher, practitioner, policymaker and industry leader to deliver on the future of public key infrastructure. The tremendous progress in digital transform has redefined now how we live, work and transact. From e-governance portal to online banking, from cloud-based service to mobile platforms, mobile payment systems, trust in digital transaction is paramount. And PKI stands at every heart of this trust framework. So public key infrastructure has evolved over decades to provide the authentication, integrity, confidentiality, and non-repudiation, a pillars that safeguard to the digital ecosystem. What was once a niche cryptographic technology has now become a synonymous with secure communication and global trust, protecting billions of transactions every day. So India's initiative from Aadhaar-enabled service to the digital locker, UPI, underline the critical role of cryptography, strong identifying system and key management enabling the secure digital society. So reflection of this PKI ecosystem, it is not just a cryptographic algorithm, it is a robust framework. It includes the cryptographic innovations. We have been using the different kind of cryptographic algorithms like RSA, ECC, post-quantum schemes are building a block of the secure key exchange in signatures. Similarly, like protocol and standards like TLS, AppMime, SMIME, IPsec, ISO, ITU standard ensure the security. Similarly, in the earlier talk from the bell, we have to work on the software and hardware security modules, and PKI is strengthening by secure hardware implementation in library. And we have to have a human expertise and research. And these conferences like IndoCrypt and various conferences in India, conference like PKIA, foster knowledge exchange and collaboration. So this is a wonderful conference where many of you have learned about the public key infrastructure and how we are going to use this public key infrastructure. So I welcome you all in this panel discussion. Thank you.
Thank you, sir. Thank you, sir. Now I request the other panel members, Hemavathy madam and Saurabh sir, to be on the dais. Yeah, please. So the first question goes to Hemavathy madam. Madam, actually the challenge. Hello. Yeah. The first question goes to Hemavathy madam. Actually, the challenge is on crypto agility, because you know that the post-quantum cryptography algorithms are maturing and new algorithms are coming up. So we may not be, we have to plan ourselves because the implementation has to be very agile to move from one algorithm to another. So in that scenario, how do you think we should approach the problem?
Yeah. So crypto agility is nothing but how do we adopt to newer cryptographic algorithms in our systems, network, resources, like everywhere. Encryption and digital signing is everywhere, omnipresent, in be it your switches, your routers, your servers, your desktop, your application. Any resource has to ride on the principle of authentication non-repudiation, integrity, privacy, confidentiality, these attributes. So crypto is going to be the integral part of all of these resources, virtual resources including. So crypto agility is very important with the advent of quantum computing scenario what we are facing. Like capture now and do the analysis or encryption later. Hostile nations across can capture our important communication because I come from a defense industry and we serve defense customers. That is going to be very, very crucial. There is a well set process and procedures as far as the cyber policy committee has laid out for any kind of encryption systems which are deployed across forces. But then at the advent of quantum computing, how are we going to address this? There comes the agility part which we need to put out in a large scale, because many of the systems which are deployed are legacy systems wherein there are hard-coded keys or algorithms. It will be difficult to upgrade the resources of the hardware which is already gone and deployed in the field. So how do we address this? There should be a framework which has to be coming in. As far as PQC is concerned, again we are relying on the NIST based algorithms, but for our defense forces, it rides on the principle that no standard algorithms can be, systems cannot be deployed with standard based algorithms, and we need to proprietary write the algorithm which is being evaluated by agencies like SAT, DRDO, and mathematically it has to be as sound as any other traditional systems. So it is long way to go. So proprietary PQC algorithms has to be written. Then, we are working with other agencies, government agencies like SETS, CDAC also. We are very closely working with, and we will have to gear up for being agile as far as our products and systems are concerned. Thank you.
Thank you, madam. Thank you for throwing the light on that. So now my next question is to Mrs. Saurabh. Global digital platforms, including Google, so they have different priorities. So one of the things for the end user point of view is to ensure there is an ease of use. But assuming that if I am a global user, and how do you, but you know that the trust is local trust angle, say India has its own root of trust and every nation has its own root of trust. So how do you provide the ease of use or convenience from as a global user? You can tell me from your payment perspective also, so that will help us throw some light on this.
Yeah. So I think experience is what has contributed to this scale. And if you look at Google, it has multiple products with each billions of users, 9 plus products. So that ease of use is something where we don't compromise. And that's where there are so many products which has been being used by billions of users, and then many more that are being used by 500 million plus users. So that is one thing. And the other thing is security. Like I was mentioning, that commitment to security is the foundation. So definitely there has to be a balance between those two. And it is also necessary to kind of evaluate both. Right? There is no single equilibrium that you can just kind of weigh two and then see which one weighs more, right? But then we also kind of look at what is the ease of use feature versus what is the blast radius of any security issue, and then we kind of take a call. And then in most of the times I will say that the security issue will take precedent over a minor experience glitch.
So that's a very interesting and important point. So I know it's a tricky balance that we need to maintain between security as well as the user convenience part. And of course, you said that security will take precedence over convenience. So that's a nice point. So going forward, Dr. Indivar Gupta sir. Sir, my question to you is that you know that one side the PQC algorithms, post-quantum cryptography algorithms, are being standardized by NIST. But on the other side, we are also seeing nations adopting and some nations implementing and developing their own requirements. Say, for example, they may be developing for their own specialized requirements and needs, maybe for different devices and stuff. So, do you think they can coexist together, and will it be beneficial to develop multiple or maybe more number of such algorithms which are post-quantum resistant?
Yeah, well, our Bell also, Madam also said that, many defense or many user agency, we have to have a proprietary algorithm. So, in that way, if you are having multiple algorithms, definitely it will be useful. In public domain, public domain algorithm, we have a lot of pools of algorithms in that is through the NIST competition and other things. And many commercial applications, we are using these algorithms, like whether it is crystal kyber or lattice based algorithm or code based algorithms, right? And but as per our policy, that you know that we have to use a proprietary algorithms only. So if we are having our own algorithms and having the same security level, definitely it will be useful for us.
Okay, sir. Thank you. And my next question to Hemavathy madam. This is because you talked about zero trust also. So now, do you think that meaning the PQC will also get implemented into zero trust, and if so, any challenges that you think it has to be addressed for taking up this zero trust as enterprises?
So presently, if you see zero trust network architecture, there are various products which are coming in the market, and there is no standard way to adopt zero trust architecture. Each of the OEM or product offering is proprietary in nature. First thing is there should be a standard, then again it is again going to work at the application, user and device level, which is giving very granular level of access, and no doubt that we need to upgrade to quantum safe algorithms, and so once there is a standardized framework, then it would be much easier. For civilian sector, we can definitely go ahead with the standard-based NIST certified algorithm adoptions. For defense sector, we need to really see how do we complement with proprietary algorithms which are already, which will be evaluated by agencies like SAG, DRDO.
Thank you, madam. Next question is to Saurabh. So, globally, you know that blockchain and decentralized networks are taking shape. And then there is the self-sovereign identifiers, SSI, is also taking shape. So in that scenario, you know that currently we are approaching the digital trust problem in the form of the centrality, the central node, and that is how the trust is being propagated. So do you think that digital trust may become decentralized, because you have the global perspective? So what could be?
Yeah, that's an interesting question actually, right? Because there are both the aspects. While we are saying that these existing algorithms, existing protocols might be breached in very short amount of time, but if we see, we are also kind of making maybe equal or maybe almost equal progress on the chip side, on the compute side, right? So there is one possibility that it will catch up, and we will have more strong compute system at a centralized level, which will continue to hold the trust part. And of course, I mean, you never know in which direction you go. It is also a possibility that you have to fall back to decentralized system. So while it is difficult to say, I think it will be a catching up game between both of these, and only time will tell whether we are going to centralized way or decentralized way.
Yeah, That's, I think I agree and I concur with your point because time will tell. Again, if someone, maybe just to, this is my perception, I would like to add to it. So if somebody wants the trust of the nation or maybe to go with the legal prevailing rules of that particular nation or region, then probably centralized trust can be a better solution for them to approach, because if there is any issue they can easily approach. Yes. That's one of the point actually, which is, this has just occurred to me, so I thought I'll share it with you.
Yeah, but however I feel, there will always be use cases for centralized trust system, right? Not everything probably can be decentralized, but then there will be good amount of application which rely on decentralized trust and few which will continue to rely on centralized trust, which will have those muscles to have those sort of compute power that users can rely on them.
Yeah, that's an interesting point. So you said about compute power. So I ask a related question to Dr. Indivar Gupta, sir. So you know that, sir, digital trust is required for IoT devices also as well. So you know that IoT devices are getting miniaturized in size and proportion each and every passing day. And how do you think we will have to address the post-quantum cryptography in those kind of algorithms? Of course, we know the latest NIST standardized ASCON, but any thoughts on views on that, sir, from your side?
Yeah, initially, if you see that 3 decades ago, most popular algorithm used to have a RSA. And later on, people were finding difficulty to have a ECC because of the implementation issue. After that, we have done, with the research committee, a lot of work done with respect to the hardware implementation and software implementation. In similar way, now that we have started work on the post-quantum cryptography, and we are trying to reduce the complexity and we are trying to optimize the implementation so that this kind of implementation can be fit into the smart hardware. In fact, because this is the PKI conference, and our government also want to mitigate this from classical algorithm to the post-quantum and post-quantum token also. So, after some time, you will find that we will have an algorithm which we can realize in the smart platform as well as in the IoT also. So there will be not a big issue. Initially, we face the challenge. After sometimes, we will have optimized implementation, and we will optimize implementation, and we can implement this kind of post-quantum algorithm or proprietary algorithm or NIST algorithm in small hardware. So we will be able to cater these things in IoT as well.
Yeah. Thank you, sir. Thank you for your valuable comments. Now I open the floor for questions. Yes, sir.
This is about the crypto agility and about native or proprietary algorithms. Those are related. Hemavathy. See, I have this take. Anyway, there is going to be a world of hybridization in all matters, in algorithms, in platforms, in hardware, in the science also. So that what I mean is there is a room for everyone to play. So I have been making some calculations. Simple. Why not use a RSA 16 kilobit signature key? Today we use 2048. And in fact, I saw some big stuff in the channel. Researching on cause of error correction and so on. Quantum, it scales up radically. Best results I'll show you. So 16 kilobit of RSA is for future. And obviously it's going to take about 500 times slower than 2048 implementation. But that doesn't matter, it's 2 seconds. Now, daily transaction, a very important transaction, bank-to-bank reconciliation, one would do that. The lower level janta, armed janta like us can do a that is based activity. and so on. The point is, high profile stuff requires care of a certain kind. So 16 kilobit of arresting, or even let's say at 1048 ECC, okay, it's impossible. I will show you even for 2048. So that's one. So crypto agility means agile on different fronts. Lightweight, medium weight, heavy weight. You should do that. And of course, it requires lots of systemic changes as well. Platforms, implementation, end-to-end stuff. I agree. Protocols, everything. That's one. That's my comment I take. And I think this thing will be researched in the coming years. And the second point about proprietary. See, it's not going to be proprietary as a secret. Public key cryptography will inherently be public domain. Okay. Having said that, we all know in crypto world, private domain or symmetric key can be proprietary. Okay. You can afford to do that. So, having said that, there is a lot of new math, a lot of old math which is not been successful. Like lattice was quite known 60 years ago. Codes were known 50 years ago. They have surfaced now. Okay. Similarly, braid groups, called group knot theory, a variety of new things. Old things, more difficult today, might come back. So this is a point. So the proprietary should be based on some resurrection of some very good, simple ideas from science, which is math, and build them on. So this, I think, can be a native effort, can be there, but it will be in the public. That's the point. But proprietary should not be confused with the public domain. That's the point. Thank you.
Thank you, sir, for your valuable insights. Any other questions from the audience? Okay.
One important point I want to say with when we are talking about the IoT or small device, so we not need to go that level of security which is required for the strategic communication. Because the small device the message is very short and and we have to keep very confidentiality for very limited time. So sometimes we don't have to take the very bulky parameters. We can also work with the lighter parameters considering the requirement of the users. So that way, in the current scenario, we can use the PQC algorithm with the lighter parameters and lightweight devices as well in the current scenario. And sir also said that Benny sir, can we work in the RSA and other things? Yeah, because working RSA with 16K is again we can always work. But only problem that implementation issue in the small devices and something. Otherwise, when we and second thing, ECC 1024 exactly because it will also have a very good level of security, but still we have some kind of exemption with that. Because factorization problem will be harder and other things. So that is why people have started working in the post-quantum cryptography. But current classical cryptography is taking the higher dimensional parameters also can be considered as a secure as well as if we are working with the higher parameter the classical cryptography as well. So we can consider it as currently it is secure. Not we can immediately say that even we are taking the higher parameter and then we can break the system. So if we take the higher parameter large key size and the ECC 1004, still we can consider it secure at this moment.
Thank you, sir, for the inner details of the algorithms, meaning how we can take it up forward this one. So I think with no further questions, thank you all the panel members for being here. Thank you, sir, Indravir sir. I know that despite your busy schedule, you figured out and you accepted my request immediately to be part of this panel. Thank you so much, sir. Now I request Dr. S.D. Sudarshan sir to felicitate our panel members. Yeah. Yeah. To Ms. Hemavathy madam, let's put our hands together. Sir, I request you to felicitate Mr. Saurabh Mimani. Yeah. Thank you, sir. Yeah. For a photograph.